was in the previous class we have discussed distance formula and few problems based on that distance formula. Now, in this class, we should discuss section ratio formula. Section ratio formula. Now, first of all, we should discuss what this word stands for. Was in coordinate geometry, if you choose two axes, yeah, one as x, another one as y, and suppose we have 2 points. The first one is A and the second one is B. A and B are the 2 points. Let us take the coordinates of this point A as x1, y1 and coordinates of this point B as x2, y2. Now, if we join this line segment AB by means of a line, if we join the 2 points, the shortest distance between them we have discussed earlier, then this line segment AB, it contains infinite number of points on it. If we consider any one point on this line segment AB, say the point is C, this point C. Now this point divides line segment AB in 2 parts. One part is AC and another one is CD. If the ratio of 2 parts, that is AC is to CD, is equal to M is to N, then what will be the position of point C, or what will be the coordinates of point C? Meaning the coordinates of point C. This technique to find the coordinates of point C, we will discuss here in this part, section ratio. Now suppose the coordinates of point C are x and y, say x comma y. For example, say x comma y. We need the value of x and y. If a line segment AB joined by 2 points A x1 y1 and B x2 y2 is divided by point C in the ratio M is to N. We have to find the value of x and y. To find this value, let us draw a perpendicular AB from A on x-axis. Boys, you know the coordinates of point A are x1, y1. So the abscissa for this point is x1. Therefore, if this is the origin, then coordinates of B will be x1, comma 0. You can easily understand x1, so x1, comma 0. If we draw a perpendicular from point C on x-axis, say CE we have perpendicular. If we have assumed that coordinates of point C as x, comma y, then abscissa of point C is x. Therefore, coordinates of E we can take x, comma 0. Similarly, if you draw a perpendicular from point B, say BF, from point B, a perpendicular here. So the abscissa of point B is x2. Now the coordinates of this point F will be x2, comma 0. But now let us draw a perpendicular AB from A on C and a perpendicular CH from AC on FB. On FB. We have drawn perpendicular. Now what happens? You see, this length is x. This whole length is x. And this length is x1. So, this length will be x minus x1. Now, since this is a rectangle, we have discussed it earlier. Since this is a rectangle, so this length is also x minus x1. This whole length from here to here is x2. And this length is x. So this length will be x2 minus x. This length. And as this length is x2 minus x, this one is a rectangle. So this length will be x2 minus x. You can see. Now this whole length from here to here, this length is y1. This length is y1. So since this is a rectangle, this length will be y1. This whole length is y. So what about this length? This length should be y minus y1 from here to here. This length. Y minus y2. The whole length y. And from y, if we subtract y1, we will get y minus y. Again, in the same fashion, you see here this length is y2. And this length is y. This whole length is y. This whole length is y2. So this length will be y2 minus y. Now consider two right angle triangles, this triangle as well as this triangle. Consider these two triangles. Now you see here, this angle is 90 degrees. This angle is 90 degrees. It is clear? Now, this angle is equal to this angle. Why? Well, as you see here, this line is perpendicular on x-axis. This line is perpendicular on this line. And this one is also perpendicular. So the two lines are perpendicular on the same line. Therefore, they must be parallel. And for two parallel lines, this one is transversal. So in class 9 and 10, you have done this angle is equal to this angle, the corresponding angle. And similarly, this angle is equal to this angle. Now, we can derive our result using only one, this taking by taking only corresponding angle, this angle is equal to this angle. But here, we have discussed that the two triangles are equiangular. You see here, this angle, the angles in this triangle and the angles in this triangle, the angles are same. If two triangles are equiangular, their corresponding sides are proportional. So what we have here we have the corresponding side, that is angle, that is side opposite to 90 degrees, AC, divided by the side opposite to 90 degrees, CD, is equal to the side opposite to this angle, this one, that is CZ, is equal to the side opposite to this angle, because this angle is equal to this angle. What? BH. Again, this is equal to the side opposite to this angle, that is AG by this one, CH. You see that. Two triangles here are equiangular. And for two equiangular triangles, their corresponding sides are proportional. And we have applied this result, proportional result here. Now what happens? You see AC by CD is equal to M by N. See, it is given that point C divides AB in the ratio M square. So AC by CD is equal to M is to N. Again, what about CZ? CZ is the length. You see here, CZ. This length is Y minus Y1 divided by, what about BH length? This length, Y2 minus minus, sorry, here it will be y2 minus y. y2 minus y. y2 minus y. y2 minus y is equal to AC. AC is the length, this one. AC, that is x minus x1 divided by, what about the length? CH, that is x2 minus x. You see, here there was a mistake in writing here. It should be y, not y1. You know, this whole length is y. So from this total y2, if we subtract y, we will get y2 minus 1. Okay. Now boys, say this result is number 1. From here, if we take first and last, what we will get? You see, m by n is equal to this one. So what we will get? M by n is equal to x minus x1 by x2 minus x. This thing you will get. Okay. Now, if you cross multiply, what you will get? Mx2 minus mx is equal to nx minus nx1. This result you will get. Now, take term containing x to one side and rest turn to another side. Mx2 plus nx1 is equal to nx plus mx. This thing you will get. Now you can take x common here. So after taking x common, in the bracket you will get n plus n. So what should be the value of x? Here, from here, x is equal to, take this one to denominator. So x is equal to mx2 plus nx1 divided by n plus n. This will be the value of x from first and last. Again, if we take first and second, in the same fashion, if you do it, cross multiply and take term containing y to one side and rest term to another side, you will get y is equal to my2 plus ny1 by m plus y. So these are the values of x and y which we have derived here from section ratio formula. And to get the coordinates of point C, which divides AB in the ratio n:n, we frequently apply this formula for x and y. So you must keep in mind this formula. Okay. One more thing was, suppose we have drawn here a line segment like this. Say this one is the line segment, this one is A, this one is B. Now, A is x1 by 1, B is equal to x2 by 2, and the coordinates of point C, which divides AB in the ratio m:n, is x, 1. Now, to get the value of coordinates of point C, we apply this formula. And this division is called internal division. Internal division. Internal division. This one is called. Internal division means this point C lies within line segment AB, and that's why it is called internal division. One more thing. Suppose C becomes the midpoint of line segment AB. Say C is the midpoint. Then the position of C will be somewhere here. Now, if this is the value of C, then the two parts AC and CD are equal. Ratio will be what? 1:1. So instead of n, you should take 1. Instead of n, you should take 1. So what about the midpoint formula here? From here, we can derive midpoint formula as x is equal to x1 plus x2 by 2, comma y is equal to y1 plus y2 by 2. You see here, put n is equal to 1, n is equal to 1. So 1 plus 1 it becomes 2. So x2 plus x1 by 2, y2 plus y1 by 2. So x and y, it provides you the midpoint formula if C becomes the midpoint. So to remember this midpoint formula, what you have to do, you have to simply add the x coordinate and then divide it by 2. Means just find the average for this midpoint. x1 plus x2 divided by 2. y1 plus y2 divided by 2. This is the midpoint formula. One more formula is here. Why? Suppose we have a triangle. Say ABC is a triangle. Now suppose coordinates of A, B and C are x1, y1, x2, y2, x3, y2. The 3 points for coordinates of vertices of a triangle ABC are given. Now, if it is asked to find the centroid of the triangle, you know, all of you know in class 9 and 10, centroid is the point of intersection of medians of a triangle. So, medians, if we draw a median, means if we take the midpoint D of BC and if we join AD, this one is a median for this triangle ABC and our centroid lies on this median. So centroid, you also know that centroid is a point G which divides this median in the ratio of 2:1. You know it? It divides in 2:1 ratio. Now suppose we are interested to find the coordinates of G. Say the coordinates of G is x, y. Let the coordinates of G are x, y. Now, how to get the coordinates of G? You know D is the midpoint of BC. So how to get the coordinates of midpoint using midpoint formula? So x coordinate of B x2, x coordinate of C x3. So the midpoint D has coordinates x2 plus x3 by 2, comma y2 plus y3 by 2. So this one is the coordinates of point D. Now after getting the coordinates of point D, how to get the centroid of the triangle? Because this centroid divides median AD in the ratio 2:1. So x1, y1 is here. So this works as x2, y2, and this will work as n, and this will work as n. So if you apply this internal division formula, that is x and y for x and y, you will get the centroid. Now you see here how I am applying this formula. Now for x is equal to, if you write it, x is equal to n means 2 into x2. x2 means what? This works as x2 by 2. So x2 is x2 plus x3 by 2 plus 1 into x1 and divided by 2 plus 1. Now you see here, this 2 cancels out with this. So what we will get, x is equal to x2 plus x3 plus x1 divided by 3. We can write it in a systematic manner that x is equal to x1 plus x2 plus x3 by 3. Similarly, if you apply this formula for finding the ordinate of the centroid, you will get y is equal to y1 plus y2 plus y3 by 3. Well, as you know, centroid is the center of gravity of the triangle. And this center of gravity you can obtain by taking the average, that is x1 plus x2 plus x3 by 3 dividing it by 3, y1 plus y2 plus y3 dividing it by 3. So this one is the centroid formula for finding the centroid of a triangle, which is formed by 3 points A, B and C. Now, we have discussed the internal division formula. in this topic, we have one more division. That division is called external division. Now, what it stands for? External division. Actually, this concept of section ratio is similar to the concept of vectors. Is similar to the concept of vectors. It is nothing but just like a displacement. Displacement means, suppose, take an example. Suppose you are at Kolkata, say K, it represents Kolkata, and you want to reach to Delhi, say D, Delhi. You want to reach. Now from Kolkata to Delhi, for internal division, if you use the mode of transport by train, then from Kolkata to Delhi, you have to make a big journey at some point. That is at some intermediate station, any one station. You can leave the train and then board another train. So what happens? Say from Kolkata you have started your journey. You have boarded the train here, and then at Asansol there was a break journey. Say A stands for Asansol. From Asansol you have boarded another train and arrived at Delhi. Now this one is your break journey point. Now this break journey point lies within this your journey from Kolkata to Delhi. Remember, you are going from Kolkata to Asansol, then from Asansol to Delhi. Your displacement is from Kolkata to Delhi. This is your displacement. But one more thing may be there, that you may take a flight from Kolkata to Islamabad. And from there, you can board some Jhota Express and then you can arrive at Delhi. Now what happens? Your displacement is from Kolkata to Delhi and your break journey point is Islamabad, or you may take a flight from Kolkata to Dhaka. Yeah, Dhaka. Say DH, Dhaka. And from this Dhaka, you can take a flight to Delhi. You see here, Kolkata to Dhaka and then Dhaka to Delhi. What happens? Here, your break journey point is Dhaka. In this case, your break journey point is Islamabad. Now, what happens? Your displacement is from Kolkata to Delhi. For the same displacement, we have our break journey point outside this line. So, this point divides your displacement in two parts. And this point is called the external point. And it divides externally. This is the meaning. One more thing, boys. Corresponding to each and every internal division, we have an external division provided the internal division is not a midpoint division. Remember, if AB is a length, and suppose this point divides AB in some parts, say A is to N, then corresponding to this internal division, with this ratio, we will have one more external division, which the point corresponds somewhere C1 here. And its ratio will be same. How? You see here. One more thing is there, important here, that if C is the midpoint, then in that case you will not get any external division. But if C is not a midpoint, it lies here. Or here, if it is left of midpoint, your external division corresponds in this direction. If it is right of midpoint, your external division corresponds in this direction. Let us take an example to prove it. Suppose wires, this length is 3 units, 3 meter. See, this whole length is 3. This length is 2 units. And this length is 1 unit. 2, 1. So 2:1 is the internal ratio. Now suppose we have doubled this length. This one is 3 units. If you double it, say up to C1, what you will get the total length from A to C1, this total length is 6 units. And from C1 to B, what you will get? It is again 3 units. Now, if it is 6 units, it is 3 units. What about the ratio? M is to N. You observe it? M is to N is 6 is to 3. Again, it is 2 is to 1. You see here? This one is the internal division 2 is to 1 ratio. And corresponding to this internal division, if C point internally divides AB line segment in the ratio 2 is to 1, then we must have an external point which divides AB in the same ratio. That is 2 is to 1. So corresponding to each internal division, we have an external point which divides externally, but the restriction is that point for internal division should not be the midpoint. Now, one more thing is important, that in this internal division, if you consider your displacement, you have to displace yourself from A to C in this direction, and then from C to B in the same direction. But in case of external division, you see that from A to C1, this displacement, the direction of this displacement, and from C1 to B, the direction you can observe, this direction, the two directions are opposite. So if M is positive, N should be negative. So you will get the external division formula if you consider one of that M or N to be negative. So in case of internal division, we have the point C, the axis and environment of the point C as xy, that is for internal division x comma y, we have written mx2 plus nx1 ym plus n, comma my2 plus my1 y m plus n. And for this one for internal division, and for external division, the same point xy can be written as mx2 minus nx1, because if we assume the sign of n as negative, your displacement in reverse direction. So minus nx1 by n minus n, and here you will get ny2 minus ny1 by n minus n. So this one is the formula for external division. Yes, you can derive this formula by the same concept. This will depend on you. Now, this one is external division. One more thing is important. If you are applying internal division formula and for any problem, if you get my n, it is positive, say 2 by 3. If it appears as 2 is to 3, then this is the case of internal division. But somewhere, if it appears as minus 2 by 3, suppose, then in that case, this n minus n ratio is negative. It implies that the point divides externally if the ratio 2 is to 3. Don't take minus. Minus indicates that your division is external division and the ratio is 2 is to 3. Remember, any ratio is never negative. So minus it implies only the case of external. But so this is your concept for section ratio so far. Means in this concept you have to write internal division formula, then midpoint formula, then centroid formula, and then external division formula. Let us take few problems based on this topic. Suppose it is asked to find the coordinates of a point. The coordinates of a point on x-axis, you write here, find the coordinates of a point on x-axis which divides the line segment joining 3, 4 and 2, minus 3 in some ratio. In the ratio, you can write in the ratio, m is to. Also find the coordinates of a point on y-axis which divides it in the same region. In the same region. This is the problem which we are discussing. Now, to discuss this problem, first of all, we have to prepare two examples if you want to learn what this problem stands for. You see, what? Suppose we have two axes here, like this: origin, x-axis, y-axis. The two axes here. Now the first point was 3, 4. If you observe it, first point was 3, 4. So it lies in first quadrant somewhere here. See, 3, 4 somewhere here. And the second point was 2, minus 3. Let us take point somewhere here. 3 minus 4. 3, 4, this one. And 2 minus 3 lies somewhere here. See, this one. This one is A. And this one is B. 3 minus 4 lies in 4th quadrant. 2 minus 3 lies in 4th quadrant. And 3, 4 lies in first quadrant. Now, if you join the 2 points, if you join this length is divided by x-axis at some point C. Now, if you want to write the coordinates of point C, it should not be x comma y, it should be x comma 0. You see here, x comma 0. Now remember, the join of A to B, your displacement is from A to B. Displacement is not from B to A. Remember it. You have to keep in mind that A to B is our displacement. So this ratio should be treated as M. This one is 3, 4. This one is 2, minus 3. So this treated as x1, y1. This treated as x2, y2. And here m is to n. Now, for point C on the x-axis, we know that the coordinate of any point on x-axis is 0. So for point C, we have coordinate is 0. So if we take the second formula, that is formula for coordinate, we can apply it here, and what we will get? 0 is equal to y is equal to m. M is this one, and into y2. M into y2. That is m into the value of y2, you can write minus 3, plus n into the value of y1, you can write 4, divided by m plus n. This thing you can write. Now, after cross multiplication, what you will get here? 0 is equal to minus 3m plus 4n. Now, this 3m you can take to the side. 3m is equal to 4n. So, m by n, this ratio you are getting that 4 by 2. Means this ratio m is to n is 4 is to 3. Means x-axis divides the line segment in the ratio of 4 is to 3. Now, as we have taken this one as 4 and this one as 3. Now, you are able to find the value of x by applying the formula for x. So, what happens? For x, we have x is equal to m into x2. M means 4 and x2 means 2. So, what happens? 4 into 2 plus n means 3 into x1 means what? 3 by m plus n, that is 4 plus 3. You can observe it. 4 into 2, then plus 3 into 3 by 4 plus 3. So what happens? 8 plus 9 by 7. 8, 9, 8 and plus 9. So 8 greater than 17 by 7. So what about the coordinates of point C? The coordinates of point C will be 17 by 7, comma 0. This one is the coordinates of point C, which divides AB values and giving the ratio m is to n. Whereas you must observe these calculations. There may be numerical errors. You just clarify that numerical errors if it happens while writing. Now, one more thing. Here, we have to find the point on y-axis which divides AB in the same ratio. What it means? If we extend this line segment AB, then this line segment AB cuts y-axis at some point. Say it is C1. Now we need the coordinates of C1. But from A to C1, if you observe, if we take this ratio as n, and C1 to B, if we take this ratio as n, then this is the case of external division. And for any point on y-axis, we have 0 as its abscissa and y as its coordinate, 0, y. So apply 0 is equal to, using external division formula, you will have 0 is equal to nx2 minus nx1 by m minus n. From here, you will get the ratio m is to n. And after getting the ratio m is to n, you are able to find the value of y, so that you will get the coordinates of line C1, which divides the line segment AB externally in the same ratio. Now this thing is left for you for your homework. You do it at home. Now boys, try to practice more and more problems at your home from recommended book. I have already recommended the book of SND for practice these problems. So you must practice more and more problems based on distance formula as well as on section ratio formula. Thank you boys for this class. We will discuss in the next class next topic. Thank you.